factoring, or GCF. So GCF is an acronym that we give to the greatest common factor. And the greatest common factor is the largest factor that you can divide evenly into every single term within that polynomial. So it's the largest factor that you can divide all terms in a polynomial by. And right now that just seems like a sort of confusing definition, but you're going to see as we go through some examples what that actually looks like. So the factor itself, so the greatest common factor, can be a number. So the factor can be numbers. So for example, it could be 3, it could be 6, it could be -9. It could be a variable. So it might be x, could be x squared, whatever letter it happens to be in the question, or it could be a combination of numbers and variables. So it might look like 4x. Or -2x squared. So those are some examples of what your greatest common factor could look like. So it could be a number, could be a variable, or it could be a combination of both. So we're going to look for the greatest common factor for each of these sets of terms first before we look into how to factor using the greatest common factor. So what is the largest number for part A that will divide evenly into both 12 and 9? So we want a number that will divide evenly into 12 and 9. So it can't be any larger in this case than 9 because 9 is the smallest number out of these two terms. So what number will divide evenly into 12 and 9? Well, the largest number that does that is 3. You'll always have a 1 as well, so that's important to remember. But the largest or the greatest common factor is going to be 3 in this case. So in part B, what is the greatest common factor for 4 and 6? So what is the largest number that will divide evenly into both of these numbers? Well, in this case, it's going to be 2. Because 2 will divide evenly into 4 and 6. And then, what is the largest term, or the greatest common factor, that will divide evenly into x squared and x cubed? So you might think it's just 1, right? Because there's an imaginary 1 in front of each of these terms. But when we're dealing with variables, we have to think about our exponent laws. So x to the power of 3 can be written as x times x times x. And x squared can be written as x times x. So x squared has 2 x's and x cubed has 2 x's. So the greatest common factor is actually going to be x times x, or in this case, it's x squared. So that's important to remember. So sometimes it could be an actual variable because x squared actually divides evenly into x to the power of 3. So I know this can be sort of confusing to think about it at first. So if you have any questions about this, please make sure you post your questions in the appropriate discussion board, or please send me an email. So let's see what this looks like for some examples. So we're going to look through some steps, and we're going to think about how to use those steps to sort of common factor. So the first example, we have a polynomial that is 3x squared plus 6x minus 3x. So we want to look for the greatest common factor. So I always think about this in terms of steps. So what is the number? What is the largest number that will divide evenly into each of these terms? Well, in this case, it's going to be 3. 3 divides evenly into 3, 3 divides evenly into 6, and 3 divides evenly into negative 36. And so once I've determined the number, I need to ask myself, do I have any common letters? So do each of these terms have a letter? Well, no, because our last term is just a number. So there is no letter that I can also use as my greatest common factor. So 3 is my greatest common factor. So the next thing that I want to do is I want to divide the trinomial by the greatest common factor. And what that looks like is I need to think about, well, once I know that 3 will divide evenly into each of these terms, and what do I have left over? So one way to think about it is if you are going to eventually, what we want to do is we want to write our greatest common factor out front. So when we're common factoring, it's going to be our greatest common factor, and then what's inside of this bracket is the remainder. So we identify our greatest common factor, and we write that in front of a bracket. And then what's left over is the remainder once I divide each of these terms by that bracket. So I'm dividing my first term by 3, I'm dividing my second term by 3, and I'm dividing my last term by 3. So 3 divided by 3 is 1, so I'm left with x squared. 6 divided by 3 is 2, so I'm left with 2x. And negative 36 divided by 3 is going to be 12, or negative 12. So this is I write my greatest common factor out front of my bracket, and then what goes inside of the bracket is the remainder when I divide each term by my greatest common factor. So I can always check my solution by using the distributive property. And that's a good strategy to use to make sure that at home you are doing these questions correctly. So let's just do a quick check. So I'm going to have 3 times x squared plus 2x minus 12. So 3 times x squared is 3x squared. 3 times 2x is positive 6x. And 3 times negative 12 is negative 36. And is that the same expression that I started with? Yes, so then I know I've done this correctly. So let's take a look at example 2. So what is your greatest common factor? So always look for first a number. Is there a number that will divide evenly into each of these terms? In our case, it's going to be 5. Is there also a letter and variable that will divide even to? So each of these terms has an x, and then what is the lowest or the smallest exponent? Well, my smallest exponent is 3, so I can factor out an x to the power of 3. So you always look for the number, so the largest number that divides. And then when you're looking at exponents, each term has to have the same letter. In our case, it does. And then we factor out the smallest exponent. So sometimes it'll be, like in our case, x to the power of 3, but sometimes it might just be an x. So the 3 is our smallest exponent. So again, we want to think about what is our final answer going to be. So we always start writing our greatest common factor. So our greatest common factor was 5x to the power of 3. And then inside of our bracket is the remainder once I divide every term by my greatest common factor. So what does this look like? Well, I'm going to divide each term by 5 times x to the exponent 3. So 5 times 5 is 1. And x to the power of 5 divided by x to the power of 3. So this is where those exponent laws come in handy. So if you have an exponent that has the same letter, so the bases are the same, but the exponents are different, you subtract your exponents. So this becomes x, and then 5 take away 3 is x squared. Now we need to think about 15 divided by 5. Well, 15 divided by 5 is 3. And then what is x3 divided by x3? Well, 3 subtract 3 is 0. And remember that anything to the power of 0 is going to be 1. So it would just be 3 times 1, which would just be 3. So this actually disappears as well. And then our last term, negative 35 divided by 5 is negative 7. And then x to the power of 4 divided by 3, or 4 take away 3, is going to be x, or x to the power of 1. You don't have to write that 1 there. So this would be my answer here. So 5 times x to the exponent 3, and then times x squared plus 3 minus 7x. So you can always check the solution by applying the distributive property to make sure that your answer will go back to the original. So 5 times 1 is 5. X to the power of 3 times x squared is x to the power of 5. 5 times 3 is 15, and then I have my x to the power of 3. 5 times negative 7 is negative 35, and x to the power of 3 times x is x to the power of 4. And was that what I started with? Yes. So then I know I've done it correctly. I know this can be confusing at first, so please post your questions, send me an email if you're struggling with this concept. And then the last example, so sometimes our common factor can also be a binomial. So our greatest common factor for both example 1 and 2 was just a monomial. So it was 3 in the first example and 5x to the power of 3 in the second example. Sometimes our greatest common factor will actually be a binomial. So in this case, I have 2a times 2 plus a minus 3 times 2 plus a. So both of these terms has a 2 plus a in it. So our greatest common factor is 2 plus a. And that's okay to have. So I want you to think about that. So if I was to then factor this, I would write, just like before, I have my greatest common factor out front, and then my remainder. So that's one way to think about it. So I would have 2 plus a, and then I'm going to have another bracket that has whatever my remainder happens to be. So if I'm just going to rewrite this just quickly over here, very small. So I'm dividing each of these terms by 2 plus a. So I'm doing it to the first term and I'm doing it to the second term. So if I have the same term on the top and the bottom, they cancel each other out. So I'm just left with 2a for my first term, and I'm left with my negative 3 for my second term. So then this becomes an expression that's 2 plus a times 2a minus 3. So you'll notice that, hey, this looks like those questions that I did in a previous lesson that looked at multiplying binomials. So this is what this would be. So that's important to think about. So your greatest common factor can be a number, a combination of a number and a letter, can just be a letter, or sometimes it can be a binomial. So keep all of that in mind as you are progressing through the lessons. As I said, if you have any questions about this, please post them in the discussion post on the virtual learning environment or send me an email.